Let's take a look at a few examples of how we're going to apply compound interest. So for example, in this problem we have amount of $1,500 is deposited in a bank account paying an annual interest rate of 4.3%. It's compounded quarterly. What is the balance after 6 years? So we're going to be using that formula that we just discussed. That is A equals P times R1 plus R over N all raised to the nt power. And how I approach these problems is I just look at the problem, I just identify what are the parts. For example, my P value is going to be $1,500. So let's go ahead and write this out. My A is going to be equal to my $1,500, which represents my P. I'm going to say 1 plus. Now I need to identify where's my R in this equation. My R is my 4.3%, but that's as a percentage. I need to convert it to a decimal. So in decimal form, that's equal to 0.043. So I want to convert that to a decimal when I come over here and put that into the formula. So you get 0.043 in there. So the next step is to find what is my N, because N shows up in two different spots. My N is how many times am I compounding? I'm compounding quarterly. So my N in this case will be 4 from the previous table we showed you. So I'm going to put in 4 into this denominator here, and then up in my exponents I have a 4, and that's going to be times how many times I compound, or how many years this is going to be compounding for. And it's going to be compounding for 6 years. Alright, so I'm going to take 4 times 6. Okay. So now I can do some basic calculations following order of operations. I'm going to take the calculation in the parentheses. That is, I'm going to take 0.043 divided by 4, and then when I get that calculated, I'm going to add simply 1 to it to complete that order of operation. So we're going to take 0.043. So if you have your calculators, you can play along. We're going to take 0.043 divided by 4. It's going to give us 0.0105. It's very important that you keep all the decimals, all the numbers showing on your calculator. So we're going to add 1 to that to give us 1.01075. And you want to keep all the decimals because we want this to be the most accurate it can possibly be when it's all said and done. And we're going to raise it to the 4 times 6, which is 24 power. So now it's time on the next step is to take care of the exponent. Again, following order of operations. We're going to take this number, we're going to raise it to the 24th power. And on your calculator, you want to look for buttons on your calculator that looks like a little caret sign, or an X to the Y, or an Y to the X button. On my calculator, I have a Y to the X button, so I'm going to push that to the 24th power, and I get a number of 1.2925555, or 1.292557881. Now, for the purpose of this, I'm not going to write all those numbers down, but I'm going to keep them in my calculator. I'm going to keep that screen up. I'm not going to clear my screen at all. I'm going to keep that number right there. So for the purpose of writing this, I'm just going to write 1.29. So I'm going to take that 1,500 times by 1.29, and just know that there's a bunch of other stuff following that 1.29. So I get my A is going to equal 1,500 times that 1.29 decimal, and I get 1938 point, and this is the key, is point. And in the purpose of anytime you're dealing with money and compound interest, you always want to round to the nearest penny. So my number is going to be 1938, and the decimal is 0.836, so that's going to round to 0.84. Alright, so my answer I get is 1938 and 84 cents. So after 6 years, my $1,500 I deposited will now be $1,938.84. Alright, now I said you want to round to the nearest penny, unless it's specified to you otherwise. Sometimes it may ask you to round to the nearest dollar, and you want to do those things, do that as well.